Hello, this is Mr. Philippek, and welcome to Probability 101, or, what are the odds? Now, you've probably heard of probability. A lot of people say, what are the chances of me winning? And a matter of fact, this little town known as Las Vegas was all built on this idea of probability. They sell that, you can win lots and lots of money, but odds are that Las Vegas will always win. So what is probability? Well, probability is the chance that something will occur. It doesn't mean it's necessarily going to happen. A lot of people confuse that. If they say you have a 1 in 4 chance of winning, people say, well, I got a 25% chance of winning. Yeah, but you also have a 75% chance of losing. I mean, think about the lottery here. The lottery has all those giant jackpots, whether it be, Powerball, Mega Ball, instant scratch-offs, whatever. They all promise, riches, but, the lottery's not dumb. They have it all worked out to, even if you bought every possible combination, you still lose because the jackpots are never quite big enough. And so my hope for becoming this future rich guy is probably few and far between. Now, here's some probability fun facts, and I think a lot of times we assume that people know that coins have two sides. There's a heads and a tail. Now, you're probably sitting there laughing, going, what in the world is this guy going over? Dice, when we talk about a die, it has 6 sides. Now, I understand there are games out there where they have like 32-sided die, but if you ever asked to figure out what the probability of rolling, let's say, a 3 is, we're going to assume a 6-sided die. And then the one that a lot of us probably aren't very familiar with is a deck of cards. There are 52 cards in a deck. There are 4 different suits: hearts, clubs, diamonds, and spades. So if we take those 4 suits and divide it by 4, we end up with 13 cards per suit. So we're going to go now over the 3 laws of probability. And the first law is just a probability of any single event happening. And an easy way to look at that is this simple little fraction here, where we have the chance of the event occurring over the total number of possibilities. So for example here, let's say we have our good friend here who wants to flip a coin. And what he's interested in is, what is the possibility of getting heads? Well, using our little fraction up here, the total possibilities of a coin, there are 2 sides. Now, how many heads are there on a coin? There is 1. So we have 1 chance out of 2, otherwise known as 50%. Now, that means that on average, given multiple trials, like every good scientist should, it should equal roughly right around a 50-50 split. Now, those people who said, well, I can flip head 3 times in a row. But as we're going to learn, that is less likely to happen than any individual flip of a coin. All right? Well, let's take a die, for example, here. What is the probability of rolling, let's say, a 6? Well, the same rules apply. Again, we make our little fraction here. There are 6 sides to a die, so that's the total possibilities here. And then the chance of the event occurring is there's only 1 6 on the entire die. So we have a 1 out of 6 chance. So that means that for every 6 rolls of a die, at least one of them, according to probability, should be a 6. All right, and so it doesn't mean it's going to happen. You might roll it 7 times and still not get a 6. But on average, again, doing it thousands upon thousands of times, 1 out of every 6 rolls, you should get a 6. Well, building upon that is the second law of probability, and it is the product probability rule. And the key terms here that we want to focus on are in a row or at the same time. Whenever you're looking at a probability problem and it says in a row or at the same time, we're going to have to use this product rule. And what that means is that we're going to have to multiply the individual probabilities together. And so let's look at our example here. Let's say a family wants to predict what is the probability of getting 2 daughters in a row. And so this is the way I set it up. So if we just say the first child and the second child here, what's the probability that the first child is a daughter? Well, there's 2 possibilities here, a boy and a girl. And so we got a 1/2 chance of getting a girl with the first one. And then for the second child, I'll change colors here. Again, there's two possibilities, boys and girls, and there's only one girl. And so using the probability product rule here, we have to multiply these two. So if we take 1/2 times 1/2, we get 1/4. And so the probability of getting 2 daughters in a row is actually less than getting a daughter with the child. And so what we're doing here is the reason why the probability is less is because, to get a daughter, you get a 50-50 chance. But to ask for that to happen back-to-back times is going to be the least likely to happen. That's why here we only get a 25% chance of this occurring. Well, what happens if we want to flip tails twice in a row? And again, we're going to kind of set it up pretty much the same way here. We have 2 coins here, so we have the first coin and then the second coin. And again, what is the probability that the first coin lands tails? Well, again, we have 2 possibilities, heads or tails. Only one tail, so that's 1/2. The second coin will be 1/2. And because we want to do it at the same time, we have to, you guessed it, multiply those probabilities. So if I multiply these 2 again, we get a similar answer to the first problem, which is 1/4. And again, that just means that this is less likely to happen than just flipping tails all by itself.